This is a 3.5 megawatt transformer that's used to provide some of the power for Titan. You can see the red conduit coming in. That's the 13,800 volt cable that comes in from our utility company, the Tennessee Valley Authority. When it comes in here, it steps it down to 480 volts, which is what the Titan cabinets need. So you see the big black cables coming out of the back of the transformer. They go straight through the wall, into a switchboard, and then out to the Titan racks. You want to keep those cables as short as possible because you want the voltage to be as high as possible for as long as you can. So we keep the 13,800 volts into the building. And then when you step it down to the lower voltage, the 480 volts, you want those cables to be short because that's where you get the electrical losses. By having those cables be short like they are, we save about $500,000 in electrical losses over the life of the Titan system. We also save, when we first started this project, we were looking at 208 volt cabinets, which would be kind of the US standard. But for a 208 volt, to get the energy we needed into each of the Titan cabinets, each rack would need 2 cables the size of my wrist. Instead, we've got 1 cable the size of my thumb by running it at 480 volts. That saved us $1 million just in the cost of the copper in the power cords for the system.
And then you were saying, what's the total power consumption of Titan?
We haven't fully measured everything. We expect it to be a little less than 9 megawatts when it's running peak flat out. It'll probably be about 7 megawatts in day-to-day operation.
Got it. Thank you.